Hello everyone. In this lecture, we'll be seeing about priority scheduling algorithm. So, in CPU scheduling algorithms, we'll be having four types like first come first serve, shortest job first, priority, and round robin. FCFS and SJFS has been discussed in the previous videos, and in this lecture, we'll be concentrating on priority scheduling algorithm. So, as priority means whichever process is given the highest priority will be served first by the CPU. So when a process comes, the process will be having arrival time, burst time, and in this scheduling algorithm, additional to it, a priority will be given to the each process. So whichever process is having a highest priority, that process will be assigned to the CPU first. In some cases, if two or more processes are having same priority, then that case will be considered, that case will be solved using a first come first serve order. So whichever process arrived first, that will be served first. So this is how the question will be given for priority scheduling. Process ID will be given, burst time will be given, and especially in this priority scheduling, a priority will be given for each process. So how to draw the Gantt chart means, as usual, the Gantt chart starts with 0. So now you are going to consider is the priority. To draw the Gantt chart, you are going to consider the priority. So now check the priority, whichever number is smallest, whichever numeric value is smaller, it means that it has the highest priority. So now here the smallest number is 1. So P2 priority is 1, that means that there has to be served first. So here in the Gantt chart, P2 has been served first. After that, and you are going to check the burst time also. The burst time of P2 is 1. So from 0 to 1, P2 is served by the CPU. Next priority goes to P5. So after 1, 2. The next priority goes to P5. So the next after P2, next P5 is being scheduled to the CPU. The burst time of P5 is 5. So 1 plus 5, the completion time of P5 will be 6. After P5, the priority goes to P1. So after 2, the priority goes to 3. That is, the process is P1. So P1 is scheduled to the CPU at the time of 6. So the bus time of P1 is 10. So 6 plus 10, the completion time of P1 is 16. After that, the priority goes to P3. So here we are going with the numerological order only. So 1, 2, 3 and finally 4. So the process name is P3. So at the 16th unit of time, P3 has been arrived and the bus time of P3 is 2. So 16 plus 2, the completion time of P3 is 18. And finally, we are left out with only one process, which is P4. So P4 will be scheduled. The bus time of P4 is 1. So 18 plus 1, the completion time of P4 is 19. So now you are going to calculate the waiting time, or you are going to find the waiting time. So waiting time of P1, you are going to consider the left side unit time. So that is 6. The completion time will be considering the right side value. For waiting time, we will be considering the left side value. So P1 waiting time is 6 and completion time will be 16. But here we are calculating only the waiting time. So we will go with the left side unit time. So for P2, the waiting time is 0. For P3, the waiting time is 16. For P4, the waiting time is 18. And for P5, the waiting time is 1. To calculate the average waiting time, you are going to sum up all the waiting time divided by total number of process. You will be getting the average waiting time. So this is about priority scheduling algorithm, and the remaining round robin schedule will be discussed in the next video. Thank you.